So we're going to look back at the customer's data set and do a few more transformations, because creating new variables through mathematical transformations of existing variables can be very handy. And two scenarios that we're going to specifically look at now are managing variables with skew, and that are variables that have very high or very low values that may inflate or deflate the average. And these are important because it can be hard to find meaningful relationships with skewed variables. But we have some tools we can use. We can use the natural log and the square root transformations to reduce skew. Dates are also important. Statistical software usually stores dates as number values. In R, date objects are stored as the number of days since January 1st, 1970. Excel does the same thing, except it looks at the number of days since January 1st, 1900. But the transformation of date values can bring useful information out of the data that can help evaluate trends, like sales trends, over time. So, looking at that customer's data set, Catherine feels the difference and percentage difference between a customer's 2017 and 2018 spending may be more useful to understanding the spending patterns than the yearly values. Therefore, Catherine wants to generate two new variables that capture the year-to-year difference and the percentage difference in spending. So first, let's create a variable that looks at the spending difference. So we're going to create a new variable in the customer's data set called spending diff. And this variable is going to be spending 2017 subtracted from spending 2018. I've hit enter to create it, and now we see, looking in our customer's data, that we now have this spending diff variable. So pause for a second and think about why we might want to look at the percentage spending difference instead of the absolute difference, because that's where we're headed next. And then you'll be able to compare the two variables and see which one you find more useful. So now we're going to create that percentage spending diff variable. And in this case, there's a little bit of extra code to round the values to 2 digits, just to make them a little bit easier to work with and manipulate. So now we can scroll over, and we see our percent spending difference, and that it is rounded to 2 decimal places, which makes it a little bit easier to read. So take a second and think about which one of these variables is more useful and more intuitive to use in your analysis. Next, let's take a look at that income variable. And a quick way to take a look at any variable is to use the summary function. So summary customers income. So it gives us our minimum, our first quadrant, our quartile, median, mean, third quartile, and our maximum value. Looking at these values, do you see some skew in this data? Maybe. Looking at our median and our mean are pretty close, but that maximum value of 167,000 seems pretty far out there, even from the third quartile. So maybe we do have a little bit of skew in this data. And when data are skewed, sometimes taking the log can help. So let's create a new variable for the log of our income. ln there is a abbreviation for log, and then we'll use the log function, customers income. Now if we scroll over, we see that that log of income has been created, and we can look at a summary of this variable. And see if there's any skew here. And it looks like we've got a really nice, tidy, normal distribution given that our median and mean are identical to each other. So this transformation may have had a really positive effect on reducing the skew in the data set. And while we're here, let's convert customers' birth dates into ages as of January 1st, 2020 to explore purchasing behaviors across different age groups. So the first thing that we're going to want to do is convert the birth date variable into a date variable. So customer's birth date, we're going to create this as date, and we've specified the format in which we want to do this. So we've made a modification to an existing variable so we don't see a new variable show up on the end. We have just ensured that the birth date variable is coded as a date. So now we want to create an object representing the date of interest. And in this case, that date of interest is January 1st, 2020. So this object is going to be called end date, and it's a date, and we're formatting it in month, date, year. And now we see under our environment tab, we have end date, and then to find the number of days between the customer's birth date and January 1st, 2020, we use the diff time function. And just to show you what that might look like, we're going to create an object called age, and we're using this diff time function with the end date, basically calculating the difference between the end date and the customer's birth date divided by the number of days in a year. So now we have a new variable for age. Now we'll want to make sure that this variable is numeric, so we can do this by using the asNumeric function. So customer's age, and then as.numeric customer's age. So what we're basically saying is that we want this to be a numeric variable. So we don't see much of a difference there. It truncated some of the decimal places, but now this value is viewed as numeric. And then if we wanted to remove the decimal places, well, we can do that too. We can do just about anything in R Studio. And I'll use the floor function for this. And now our ages, as we can see over here, are all integers. So take a moment to think about how would you go about figuring out the average customer's age? Well, one easy way to do it and to see more information about the age variable is to use that summary function. But there's more than one way to do this. So our average age is 42.26. So that's pretty cool. That's pretty handy. Another thing that we can do is use the months function to extract the month name from the birth date variable, and then the match function to convert names of months to numbers. And why might we want to do this? Well, maybe we want to create a new variable that captures the birth month of customers so that seasonal products can be marketed to customers during their birth month. I mean, I don't know about you, but I love getting my free Starbucks drink in April. So here I'm using that months function to extract that month name from the birth date variable. And we see we have this birth month variable now. And then we can do the same. We can then convert this into a numerical value using the match function. So now our birth months are listed as numericals as opposed to the names of the months themselves. And this can make it a little bit easier to work with these things in terms of statistical analyses. It's a lot easier to work with numerical variables than it is to work with string variables. So that's all I have for you this time around. We'll catch up soon and wrap up the data wrangling portion of this class. Have a good one, everybody.